Hello everyone, welcome to my YouTube channel and happy Teachers Day to all my teachers. Today we are going to see a recursive function in a C language. So in case of a C language, we have seen a functions. So if you want to see my lecture of the function, just click the I button above. In case of a function, we have defined the function, we have called the function, and finally we have seen how to declare the function. Now in case of a function, if we have to call the function within a main function, we are call it as a calling function, and the function that is written below the main, we have called it as a called function, or we can say function definition. Now if there is a scenario where we have to write function within a function, means we have to call a function, same function in that particular function, that particular concept is called as a recursive function. So in case of a recursive function, a body of a function call the same function, or we can say that function call itself. Function call itself is called as recursive function. That is also has a name called as circular definition. That is also called as a recursive function. One of the most popular example of the recursive function is calculation of a factorial number. So here, as you know how to calculate the factorial number, as if we have to calculate the factorial of 5, what is the procedure for that? We have to take a 5 first, multiply it by 4, multiply it by 3, multiply it by 2, and finally multiply it by 1. So 4 multiplied by 4, 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. In overall, it will give us a factorial of a number. So in this case, you can see here the 5, it is multiply with the 4. The same procedure is again multiply with the 3, multiply with the 2, multiply with the 1. So we can go for a simple function so that we can have the multiplication of 5, 4, 3, 2, 1 to have a factorial number of 5. So it can be done by using two ways. Two ways means we can do it by using non-recursive function. So using a simple for loop, we can do it. So to use non-recursive function to print the factorial number of 5, so we'll see it. So for starting with the program, we have to mention which library function that we are going to use. So that it's basically stdio.h, then int main, which is the main function, and then in that main function what we are going to write, we are going to print first of all, what we are going to print, we are going to say to the user that enter the number. So new line character, so user will enter the number. So for that purpose we need a scanf statement. So scanf statement will take the number, so we are going to say it as a %d, and it will be stored in at address. So we can say and a, you can use any variable. So we need to declare this variable as type int. Okay, so we have taken the number from the user and it is stored in a memory location. The name of the memory location is a. We have seen this particular concept in pointers. So now we are going to call a function. So if suppose we are saying fact is a variable, it will call a factor function. So in that we are going to send a. So this factor function will actually calculate the factorial and it will give to the fact variable, and we are going to print finally what we are going to print, factorial is equal to percentage d. We have to take it in all in this code. And which thing we have printed here? A fact. So the factor function will return a value. It will given to the fact, and fact will be going to get printed over here. So now, as we have seen, as the function is called, this particular function is called inside the main. So we can go below the main and we can declare here a factor. So we have seen that this is a function definition that we are going to write here, and this a is actual argument, right? And we are going to take it in a formal argument. It can be done by using two way, Dennis Ritchie's way or ANSI way. So we'll see it by ANSI way. So integer x. Okay, so we have to find out the factorial of this particular a that user has entered. So for that purpose, what we are going to do, we are going to we have to find the factorial of a. So this x now consists the value of a. So using a for loop, we are going to move the for loop. So we can say I equal to 0. Okay, I less than 2, I plus plus. So this is the for loop. So in this case, the for loop, we have to change the for loop as like this. So according to this particular concept, it should get 4 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So we are going to take that. It should take the initial value of x. So I will become 5 now if the user enters a as a 5. So I becomes 5 now. So we have to go where we have to go. We have to go unless and until is equal to 1. So it should go up to the 1, right? So that we have to decrement the cursor. So I will take the value of x as 5 and it will decrement the cursor. We can say I for 4, 3, 2, and it will come up to less than equal to 1, greater than equal to 1. We can say greater than equal to 1. So I is 1. The for loop will be get stopped by executing the next statement. So what will be the next statement? We have to take the multiplication of it. So we can say we can have f is equal to f multiply by I. So what is the f? So we have to declare here, this is also int f. It should have an initial value of 1 comma I. So in here f is equal to 1, I is here, this is a loop variable of the for, x is a formal argument, it will take the value of a, then it will come over here. So if I is supposed to be x means 5 suppose, so it will go here, f was initially 1 multiplied by 5, it becomes a 5, but for loop is not ended, it will minus minus becomes a 4, it will come over here, 5 was the initial value, now 4 is the multiplication to it, so 5 multiplied by 4 it becomes 20. Again it will go here, it will decrement it, it will become a 3, then it will come here over here, it will be 3. So initially it was now 20, 20 multiplied by 3 and so on. It will be done up to I is equal to 1. So x I minus minus, it will become 1. So 1 is greater than equal to 1. It is true. It will come over here. It will be multiplied by it 1. And finally, if it becomes a 0, this condition in case of this for loop will fail and it will return the statement. So what should be the return statement? It should be return f. So when this return statement will be executed when this for loop is ended. So for loops scope is the next statement. There is no for block, so it will return the statement when the for loop ends. So f will be now values of 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So let us see fs control s, then execute. You can compile it by using F9. So here the fact should be declared. It's good to have the error, so it will be beneficial for you to understand what is remaining in these things. So fact is, this is the variable that should be declared over here. Compile it again. More and more errors, it will give us more and more understanding. Compilation is done and run. So here you can see enter the number. If I enter 5, you will see the factorial is 120. 5 multiplied by 4, 20. 20 multiplied by 3, 60. 60 multiplied by 2, 120. Multiplied by 1, it's a 120. This is a factorial of a 5. You can write like, you can see the 4's value. It will be 4 multiplied by 3 multiplied by 2 multiplied by 1, it will be 24. So this is the way, by using non-recursive function, you can find out what we can call it as a factorial of a number. Now to make the recursive function using the same program, what we need integer, a fact, same, enter the number from user. It will be stored in the address of a, location a. It will be sent using this actual argument to factor function. It will be returned the factorial of that a, and it will be printed using this printf statement, same as like the previous program. What should be the changes for the recursive function? As you know, as this is the factor function, it will take the, this is actually the formal argument, it will take the value of a, the actual argument. Now we don't require for loop because we are going to use the recursive function. So I am removing the for loop, same as like I am going to remove the I value, that is the loop variable. And now as we are calling the function factor again and again, we don't require f is equal to 1 in here. If we have 1 in here, it will be reinitialized to again and again. So what we need to write in here is, so we are going to take the actual argument x. So initially if we press 5, it will take here of 5. So I am taking here x, multiply it by factor the function x minus 1. So initially it will take the value of 5 and it will go to the function again, factor x minus 1. So it will take the value 5 minus 1, 4. So it will come over here again in the, we can say, formal argument again x. X becomes 4 now. So it will return over here with the factorial of 4. Right. So again we have the repetition factor x minus 1. So it will go again as like 3, return again, it will go again as like 4, 2 actually, return again, and so on. So what we initially have in here as f is doing, if we enter a 5, it will go to print with the function as 4 factorial. It will go again to print the function as 5 factorial 2, and initially it will be 1. So when it will be 1, what we require is here, it should now go toward the value called as factor 0. So it will go to the factor 0 again into minus, again into minus. So it will be indefinite thing. So what we need to do, that whenever the x happens to be equal 1, it should return value called as 1. So what will happen in here, when factor is equal to 2 minus 1, that is equal to 1, it will go here as the formal argument in here x is equal to 1. So now here x is equal to 1, so it will directly return the value as a 1. So it will return the value means the function returns the value means now the function's scope is ended. When the function return the value, the function scope is ended. So now this fact of x minus 1 will have the value final that is equal to 1. So it will do 4, 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. So this factor x minus 1 function will be called how much times? It will call for the 4, 3, 2, and for the 1 it will return the value is equal to 1. So this is the way the factorial function of the calculation of the factorial of the given number. So you can see here, if I save it, F11 means compile and run. If I enter the number 5, you can see here a factorial is 120. Okay, so if we run it again by F11, we can have the value of 4 here, factorial is 24. If we run it again for the factorial of 1, we can have factorial is 1. In this way, using a recursive function, we can find out the factorial number. So using for loop is also very simple. Using factorial is also, or we can say recursive function is also very simple. So this is the way we can have a recursive in a function. Thank you.